When wiring a boathouse, several crucial considerations ensure safety and code compliance. Firstly, grounding is essential. A ground rod should be driven at the boathouse to establish a local grounding electrode. This provides a dedicated path to ground for the boathouse's electrical system, minimizing the risk of electrical shock. The presence of a grounding electrode system at the boathouse will ensure that any fault currents have a low impedance path to return to the source. Secondly, the main feed breaker at the house, which supplies power to the boathouse, should be a ground fault circuit interrupter, also known as GFI. A GFI breaker is designed to detect even small imbalances in current flow, indicating a ground fault. When a ground fault is detected, the GFI breaker trips rapidly, cutting off the power and preventing potentially lethal electrical shocks. This is especially important in damp environments like boathouses. The GFI breaker is supplementary to the grounding electrode system, and it is designed to protect people. Conductor sizing is another critical aspect of boathouse wiring. For a 60 amp circuit, using 3 number 2 conductors, 2 hot and 1 neutral, along with a ground wire, is appropriate. Ensure that the neutral conductor is the same size as the hot conductors to handle the anticipated neutral current. The appropriate conductor size ensures that the conductors can handle the load placed upon them without overheating. Voltage drop calculation should be performed to ensure the conductors are not undersized. A main bonding panel, also referred to as MBP, at the boathouse must be properly connected. The main bonding panel should be bonded to both the grounding electrode conductor, which connects to the ground rod, and the neutral conductor. This bonding creates a common ground reference point and ensures that neutral currents return safely to the source, preventing stray voltages and potential hazards. The purpose of bonding is to create an equipotential plane. In addition to these core elements, consider several additional factors. Use PVC conduit or other approved raceways to protect the conductors from physical damage and exposure to the elements. Seal all conduit entries at both the boathouse and the house to prevent moisture ingress, which can corrode connections and create electrical hazards. Install waterproof junction boxes and electrical enclosures to further protect electrical components from moisture. Always adhere to all applicable electrical codes and regulations. Consult the National Electrical Code, also referred to as NEC, and any local amendments. Finally, have your work inspected by a qualified electrician to ensure safety and compliance with code. A licensed electrician can identify any potential issues and ensure that the wiring meets all safety requirements. Article 250.24 covers grounding separately derived systems. Article 250.32 covers ground electrode systems for buildings or structures supplied by feeders or branch circuits. Article 250.50 covers grounding electrode systems. Article 250.52 covers grounding electrodes. Article 250.66 covers size of grounding electrode conductor. Article 250.122 covers size of equipment grounding conductors. Article 300.3 covers conductors of different systems. Article 300.5 covers underground installations. Article 310.16 covers allowable ampacities of insulated conductors. Article 314.15 covers damp or wet locations for boxes. Article 406.9 covers receptacle in damp or wet locations. Article 555 covers boatyards, docking facilities, and marinas. Article 555.3 covers ground fault protection. Article 555.11 covers wiring methods for boathouses and boat ports. Article 555.13 covers disconnect means. Article 555.15 covers bonding. Article 555.19 covers receptacles. Article 555.21 covers ground fault circuit interrupter protection. Article 555.30 covers equipotential planes. When considering conductor sizing, it is essential to select the appropriate size based on the ampacity of the circuit and the ambient temperature. The allowable ampacity of a conductor is the maximum current it can carry continuously without exceeding its temperature rating. Factors such as ambient temperature, the number of conductors in a raceway, and the type of insulation used can affect the allowable ampacity. Refer to the ampacity tables in the NEC, such as Table 310.16, to determine the appropriate conductor size for a given application. Always use the appropriate correction and adjustment factors as required by the NEC. For example, if the ambient temperature exceeds 86 degrees Fahrenheit, a temperature correction factor must be applied to reduce the allowable ampacity of the conductor. Similarly, if there are more than 3 current-carrying conductors in a raceway, an adjustment factor must be applied. Voltage drop is another critical consideration when sizing conductors, especially for long runs. Voltage drop is the reduction in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To calculate voltage drop, use the following formula: voltage drop equals 2 times K times I times D divided by circular mils, where K is the direct current constant, which is 12.9 ohms for copper and 21.2 ohms for aluminum. I is the current in amps, D is the one-way distance in feet, and circular mils is the cross-sectional area of the conductor. When selecting a ground rod, ensure that it meets the requirements of the NEC. The ground rod must be at least 8 feet long and have a diameter of at least 5/8 of an inch. It must be made of a material that is resistant to corrosion, such as copper or stainless steel. The ground rod should be driven into the ground until at least 8 feet of its length is in contact with the soil. The grounding electrode conductor, also called GC, which connects the ground rod to the main bonding panel, must be sized according to Table 250.66 in the NEC. The size of the GC depends on the size of the service entrance conductors. The GC must be securely connected to the ground rod using an approved connector. The GFI breaker should be installed in a readily accessible location. Test the GFI breaker regularly to ensure that it is functioning properly. The NEC requires that GFI protection be provided for all receptacles located in damp or wet locations, such as those in a boathouse. GFI receptacles are also available and can be used in place of a GFI breaker. When installing PVC conduit, use appropriate fittings and connectors. Ensure that the conduit is properly supported and secured. Use a PVC conduit cutter to make clean, straight cuts. Apply PVC cement to all joints to create a watertight seal. When running conduit underground, bury it at the depth required by the NEC. Use a tracer wire along with the conduit to facilitate locating it in the future. When installing waterproof junction boxes and electrical enclosures, use gaskets and seals to prevent moisture from entering. Ensure that all connections are tight and properly insulated. Use wire connectors that are rated for use in wet locations. When making connections in a junction box, leave enough slack in the wires to allow for easy maintenance and repairs. Label all circuits clearly to avoid confusion. Use a circuit directory to identify the purpose of each circuit. Keep a copy of the electrical drawings and specifications on site for future reference. In addition to the requirements of the NEC, local codes and regulations may also apply. Check with the local building department to determine what permits are required and what inspections are necessary. Working with electricity can be dangerous. Always take precautions to protect yourself from electrical shock. Wear appropriate personal protective equipment, such as rubber gloves and safety glasses. De-energize circuits before working on them. Use a voltage tester to verify that circuits are de-energized. Never work on live circuits. If you are not comfortable working with electricity, hire a qualified electrician. Proper grounding and bonding are essential for electrical safety. Grounding provides a path for fault currents to flow back to the source, tripping the breaker and preventing electrical shock. Bonding ensures that all metal parts are at the same potential, reducing the risk of electrical shock. The main bonding panel is the central point for grounding and bonding in an electrical system. It is typically located near the service entrance. The main bonding panel is connected to the grounding electrode system, the neutral conductor, and the equipment grounding conductors. The equipment grounding conductors provide a path for fault currents to flow back to the source from metal parts of electrical equipment. They are typically connected to the grounding terminal in receptacles, switches, and light fixtures. The neutral conductor provides the return path for current from the load back to the source. It is typically grounded at the service entrance. The grounding electrode system provides a connection to the earth. It typically consists of one or more ground rods, ground plates, or metal water pipes. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. The grounding electrode conductor must be securely connected to the grounding electrode system. The location of the grounding electrode system is determined by the NEC. It must be located as close as practicable to the service entrance. The grounding electrode system must be accessible for inspection and testing. Proper wiring methods are essential for electrical safety and reliability. Use approved wiring methods for all electrical installations. Install wiring according to the NEC and local codes. Protect wiring from physical damage. Use appropriate fittings and connectors. Make sure all connections are tight and secure. Label all circuits clearly. Keep a copy of the electrical drawings and specifications on site for future reference. Regular maintenance and inspection are essential for electrical safety and reliability. Inspect electrical systems regularly for signs of damage or wear. Test GFI breakers and arc fault circuit interrupter, also called a SI, breakers regularly. Replace damaged or worn electrical components promptly. Keep electrical panels and equipment clean and free of debris. Have electrical systems inspected by a qualified electrician periodically. If you have any questions or concerns about electrical safety, consult a qualified electrician. Electricity is a powerful force that can be dangerous if not handled properly. Take precautions to protect yourself and others from electrical shock. By following these guidelines, you can ensure that your boathouse wiring is safe and code compliant. Remember to always consult the latest edition of the National Electrical Code and any applicable local codes. This information is for educational purposes only and does not constitute professional electrical advice. Always consult with a qualified electrician for any electrical work.